Okay, now we're going to do another one like this. This is going to use a log rule, but it's not as complicated. Notice we have natural log x fourth plus 3 to the third. Well, we can't directly use our log rule because we have a third there. Somehow there's a chain rule involved in here, which could get very complicated. So the first thing is I'm going to simplify using log rule 3, which says that the natural log of x to the a equals a log of x. Notice in this case, a equals 3, and x is our x fourth plus 3. So I can say that y can reduce to 3 times the log of x fourth plus 3. This is a very handleable problem. I can actually use the log rule up there. I just let u equals x fourth plus 3. So du dx comes out to 4x third plus 0. And we know here a equals 3. So substituting in my log rule, dy dx, in this case, is going to be a over u. So it's going to be a, which is 3, over u, x fourth plus 3. And the derivative was 4x third. So when we put this out, we're going to get 8x third over x fourth plus 3, and that's my answer. Now notice, if I had tried to use a log rule and then have a chain rule, I could make u equals x fourth plus 3 to the third, and then it would be a chain rule, and then I have to introduce another variable. That's very difficult.
Dr. Mirabile?
Yes.
4 times 3.
4 times 3 is hold on. Did I get 4x? Yes, it is 4. That's going to be 12. I think I changed the problem here. Okay, that's why. Okay. So it's right here, but not right here. Okay. So you always have to make use of log rules and try to simplify your problem first. Don't just run to try to take a derivative. When you're dealing with natural logs, use your 3 log rules. I've gave it to you in 2 classes. I don't think I've got to give it to you again. They will be on the, when I give you the next test, the rules will be on that test. Okay, now let's go to section 11.2, which is exponential differentiation. And what we want to do here is once again put our differential rule up here in the corner. So let's erase this. Woo. Okay. One thing good about the videos, you can rerun them again if you missed it. And our exponential rule, y equals a e to the u, is dy dx is a e to the u du dx. That constant stays there. So let's take an easy one. Easy for you, right? Y equals 2e to the 3x squared. This is a fairly straightforward one. If we look at this, we have a equals 2, u equals 3x squared, and du dx is 6x. Well, now all we have to substitute is in there. Therefore, dy dx, it's a few steps, is equal to a which is 2, e to the minus 3x times 6x. So your answer is going to be 12x e to the minus 3x squared. And that's your answer. Okay, so that was a pretty easy one. Let's try one which is a little bit more difficult. I don't know if I want to do that one yet, though. Well, yeah, I'll do it. Okay. I'll do it. There is one on your quiz that I want to go over first, okay?
Dr. Mirabile?
Yes.
Where did the negative sign come from?
Oh, it wasn't there? I just added it. There was no negative sign. Evidently, I rewrote the problem. Obviously, u is 3x squared, not minus 3x squared. That was just my pen not doing what my mind told it to do. Thank you. So let's take another example. And this is from your quiz. This is quiz 5, 6. And it says, given this, y equals 1 plus e raised to the 2x over e to the 3x. Now, if you want to find dy dx. Now, you could use the quotient rule. But why? Let's simplify the function yet first. Always try to simplify the function. And I'm going to write y equals 1 over e to the 3x plus e to the 2x over e to the 3x. The denominator is divided by both numerator terms. Now, I'm going to bring this up. When I bring a power up, of course, we all know that we negate it. I'm going to bring this up also, e to the 2x times e to the minus 3x. Now we add powers, so it's minus 3x plus x. So what we get here is y equals e to the minus 3x plus e to the minus x. Making this a very much simple problem, I didn't have to do the quotient rule. If I look at this one here, u is going to be equal to minus 3x. I'll call that u1. And du1 dx is going to equal to minus 3. Notice a is 1. I don't have to worry about it. This one over here, u2. Sorry, I'm trying to get that. u2 is minus x. So du2 dx is minus 1. So this is minus 3. Let me make that more. Now I'm going to substitute these in the exponential rule. Notice what I've done is simplify this a lot. So what we get here is dy dx equals, for the first one, a e to the u du dx. The first one is a equals 1, u equals minus 3x. So it's e to the minus 3x, and du dx is minus 3. Okay, it's going to be plus e to the u is e to the minus x minus 1. So what changes here? Just the signs. So we get minus 3 e to the minus 3x minus e to the minus x. Now, could we reduce that? Well, I could factor out an e to the minus x if you want. Just showing you how the mathematics works. Factor in e to the minus x. Okay. That would be e to the minus x out here, which give you minus 3. There's going to be minus 1 here, because I took out. Now, what e to the minus x times what gives you e to the minus 3x?
E to the third.
E to the third. E to the 4x, right? Yes, no? How about e to the minus 2x? E to the minus 2x plus e to the minus x is e to the minus 3x.
Oh, of course.
This comes out here. Okay, so I've just simplified it. You do not need to do this step. Okay, unless I asked you. This is what I'm interested. Okay? So that shows you I took a problem which I could have used the quotient rule, but if I simplify it by dividing the denominator into each of the numerators and bringing it up here, it became a very simple problem. By the way, this is e to the minus 3x in case you don't read it. Okay, so now let's get back to the homework. Well, that was on your quiz. I just hope people noticed it. If you didn't, you made it a pretty more difficult problem than you would have. I'm going to go over a problem which was on the final 2 years ago. It's a very complicated problem. I don't know if they're going to give it again, but I would suggest that you write it down and figure out, pretty much do it the way I do it. So, this is on your homework, 11.2. It's called number 11. Okay, this is from your homework. And the problem is y equals 2 to the e, and it's raised to the x squared plus 1, which itself is raised to the third. And you want to find dy dx. How much time we have?
2 minutes.
Well, that looks like a really fairly complicated problem. Now, you really wouldn't use the product rule here. Okay? One way to do this is to introduce a whole bunch of different types of variables and make this a real problem. Well, the first thing that I'm going to do is I'm going to simplify the problem. I'm going to simplify the y function by using a log procedure. I have to take the natural log of both sides. So step 1, take the natural log of both sides. I'm going to call this 1. Both sides of equation 1.
30 seconds.
All right, then I would get the log of y. I'm not going to do that first, though. I'm going to do something which is, okay, so step 1 is not going to do that. I just saw a step which makes it a lot easier.
Why don't we do that on the next one?
So step 1 I'm going to do on the next one. I just saw a step which makes it a lot easier.